So what is Redux? Redux is a library that helps you manage the state of your application, and is something that you should use in medium to large single-page applications with complex data flows. So if you're building a simple application with simple data flow, you don't necessarily need Redux. And in fact, Redux can add extra unnecessary complexity in your application. So what do I mean by these large single-page applications? Well, in a typical Angular app, without the without the Redux architecture, you know that each component maintains the state and the logic behind a view. This model aligns perfectly with the encapsulation principle of object-oriented programming. However, it can be a problem when you have multiple views that are working with the same piece of data and do not have a parent-child relationship. In these situations, we often have multiple copies of the same data that are independent of each other. So when a view updates a model, we need to do some extra work to keep the other views in sync. For example, think of Facebook. On Facebook, we have three views that represent the current state of users' messages. On the navigation bar, we have this icon that shows the number of new messages. And if we're on the messages page, we have a view like this. And irrespective of what page we're on, we can also have multiple chat tabs on the bottom of the screen. These are independent views that need to be in sync. And what is important here is that they do not have a parent-child relationship. So this navigation bar is not a parent or child of other views here. If it was, then passing data would be simple. It would simply use the input properties of the child components to pass the data down the subtree. But since these views are independent, if you want to keep them in sync, we have to do some extra work. A common solution is to use events, and sooner or later, that will turn into an event spaghetti. In a large code base, we have events published all over the place, and then to track what happens to the application state, we have to jump all over the code to see what's going on. The problem with this approach is that the data can be updated in an unpredictable way. When there is a bug, we have to jump all over the code to figure out how the data is flowing and how the application state is updated in multiple places. So it's unpredictable. Also, adding a new feature becomes a challenge because once again, we don't know what is the impact of this new feature on the application state. If it's touching the same piece of data that is in different places that needs to be kept in sync, again, we have to do a lot of hard work. So Facebook had this problem back in 2014, and that's why they introduced the Flux architecture. Now, Redux is a simplified and lightweight implementation of this architecture that provides a clean and elegant solution to this problem, maintaining the application state in a predictable way. So there are no surprises. Now, apart from this, Redux provides a number of other benefits. The first one is that it decouples your application from a presentation framework like Angular. So you can implement a big chunk of your application and its presentation logic using simple functions that are completely decoupled from Angular or any other presentation frameworks. And then you can decide if you want to use Angular or maybe you want to use React. So it allows you to postpone decisions about external libraries and frameworks, which is one of the attributes of clean architecture, as you might have heard from Uncle Bob. The second benefit is that it makes it easier to unit test your application without mocks, spies, and any other tricks that can make testing both complex and error prone. Because Redux is heavily based on functional programming, so as you will see in this section, we'll be writing simple functions that take a state and return a new state. That's all. These functions are really easy to test, and this means you can write your tests before your production code, which basically means test-driven development or TDD. The third benefit is that you can get some really cool tools as part of your development. One such example is Redux Developer Tools extension that you can add to Chrome, Firefox, and other browsers. It makes it incredibly easy to debug your application by allowing you to inspect the application state in such a way that we have never seen before. This is actually one of the features that I was really impressed with, and you're going to see that in this section. And the last benefit is that Redux makes it incredibly easy to implement features like undo and redo. So if you need these functions in your application, yes, you can implement it without Redux, but using Redux makes your life much easier. Now, all these fancy benefits, of course, they come with a cost. Just like many other architectural patterns, you're going to write a bit more code and you will have more moving parts in your application. So use Redux only if you're building a medium to large single page application with complex views and data flows. Here are some scenarios. You have independent copies of the same data in multiple places. You have multiple views that need to work with the same data and be in sync. Users can collaborate and work on the same piece of data. So data can be changed by user A, and at the same time, user B can change the same data. Or data can be updated by multiple actors, so it can be changed as a result of user actions, and at the same time, it may arrive from the server, either via polling or push notifications. So if you have these scenarios in your application, you would potentially benefit from Redux. So remember, when building a new app, you don't need to automatically reach for Redux. You can always start simple, and as your application grows, then you can refactor existing components and use Redux to manage the application state in a predictable and deterministic way. Next, we're going to look at the building blocks of Redux. In Redux, we have three pieces: the store, actions, and reducers. Let's explore these one by one. The store is a single JavaScript object that contains the state of the application. You can think of it as a local client-side database. So here we can have properties like the list of messages, number of new messages to be displayed on the navigation bar, whether chat sounds are enabled, and so on. Different views and components use different parts or different slices of the application state depending on their functionality. And this also means if different components need to work with the same slice, there is only one copy of that slice throughout the application. So once a component modifies that slice, the changes are immediately visible to other components. We don't have multiple independent copies. Now, the first question you might have is, wouldn't this consume too much memory? Not really, unless you're storing 10,000 or more objects in this store. And then I would ask you, why would you do that anyway? So for the most part, it's okay to have a single object to store the application state. The second piece is the actions. Actions are plain JavaScript objects that represent something that has happened in the application. So semantically, they're more like events. If you have some background in CQRS architectural style, you should know the difference between commands and events. Commands or actions represent something that should happen, like posting a message, whereas events indicate that something has happened, like a message was posted. Actions in Redux are semantically events. Here are a couple of examples. When the user reads a message, we can represent this event using an action like this. As another example, if the user posts a message, we can have an action like this. So these are simple data structures and don't have any logic. And by convention, we use a type property to specify the type of each action. Now, an action can have additional properties related to the event that just happened. And the last piece, reducer. Now, reducer is a term that often confuses a lot of beginners to Redux. Unfortunately, the terms used in the Redux library are not very helpful. So actions are really events, and reducers can be a little bit confusing to beginners. Now, reducer is basically a function that specifies how the state changes in response to an action. You can think of it as an action handler or an event handler that determines how the state is changed. Now, what is critical here is that the reducer does not modify the state. It only returns the new state. And then the store will internally update the state. So nowhere in the application we're going to directly modify the state. This is the responsibility of the store. It keeps the state and updates it whenever necessary. So these are the building blocks of Redux. Now, these reducers should be pure functions. But what do I mean by pure? Well, that's the topic for the next lecture. So, what is a pure function? Well, a function is pure if we give it the same input, we always get the same output, no matter how many times we call that function. So, it shouldn't have any side effects. Let's take a look at a few examples. So, this function is impure because every time we call it, it's modifying its argument. So if the value of the count property of the input is initially 0, and we call this function 10 times to increment it, instead of getting 1, we get 10. So in a pure function, we should not mutate or modify any of the arguments. Here's another example. In this function, we're making backend calls via this service. And this is an example of a side effect. So every time we call this function, our application state stored in the database on the server is modified. And here's the third example. In this function, we are updating the value of the count property based on a random number generated by the mass class. So with this function, if we give it the same input, we cannot ensure that we always get the same output. The output is different every time because we are using an impure function. So in a pure function, we should not use mass.random or date.now or any other functions that return a different value every time we call them. Now let's take this first example and change it to a pure function. So instead of incrementing this count property, we return a new object with a count property, and the value of this count property would be the value of the original count plus 1. If we call this function 10 times and give it the same input, we always get the same output. So if count is initially 0 and we call this function 10 times, we'll get 1 because this function is not modifying its argument. So in Redux, our reducers should be pure functions. Now let's take this example and modify it a little bit so it looks like a reducer function in Redux. In Redux, reducer functions always take two arguments, the current state and an action. Then, based on the action type, they return a new state. So typically, we use a switch statement on the type property of the action, and based on the value of the type property, we return a new state. So let's imagine action.type is increment. Then we return a new state with the updated property. So we are not going to modify the original state passed to this function. Now, if you have never done functional programming before, this concept is new and confusing to you. I totally understand that. So you might be asking, what is the point of this? Why are we not allowed to mutate or modify the state? We always have to return a new state. Well, there are a number of benefits to this approach. The first benefit is that pure functions are really easy to test. Imagine you want to write a test for this function. You don't need any mocks, any spies, or any other tricks. You simply call this function, give it an input, and make an assertion about the output. As simple as that. The second benefit is that this approach makes it really easy to implement features like undo and redo, because we always keep the previous state instead of modifying it. And the third benefit is that it gives us a powerful tool which we call time travel debugging. So using the tool that I will show you later in this section, we can travel back in time and look at our application state as different actions are triggered in the application. We can see how the application state is modified in every step. And this makes it really easy to find bugs and fix them. But once again, it only makes sense if you're building a complex application with complex data flow. For a calculator application, you don't need Redux. But if you have complex views, complex data structures, and things have to be modified in different places, then you can look at the application state and see exactly how it's modified. All right, now let me show you how to add Redux to an Angular app. There are many implementations for Redux, but the two common implementations are ngrx/store and ng2-redux. These are the most popular ones, and they're very, very similar in terms of their API. ng2-redux is built on top of the real Redux library and is compatible with much of the Redux ecosystem. It adds bindings for Angular 2, so you can easily connect your Angular components with Redux. ngrx/store, on the other hand, has gone the route of re-implementing the Redux pattern in an Angular 2 and RX friendly way. This means it's not compatible with other libraries built for Redux. So in this section, I'm going to use ng2-redux, but I wanted you to be aware of ngrx/store because there are a lot of blog posts and questions on Stack Overflow that are centered around this implementation. All right, now before we get started, make sure you have the latest version of Angular CLI. So on my machine, I'm using Angular CLI version 1 beta 26. If yours is older, simply do npm install angular-cli-g. All right, now I'm going to create a new folder, redux-demo. Go into this folder and run ng init. All right, now if you look at package.json, you'll notice that we're using Angular 2.3.1. This is very important if you want to follow along with this lecture. Otherwise, when you add Redux, you're going to get an error in npm because the latest version of Redux is not compatible with older versions of Angular. So make sure you've got Angular 2.3.1 or higher. Now back in terminal, npm install Redux. So this is the main Redux library for JavaScript. It's got nothing to do with Angular. Then we add ng2-redux, which provides an Angular module for dependency injection, as well as some other helpers that we're going to use in this section. So add this to the project. Now, if for any reasons you're having difficulty creating a new Angular project and adding these dependencies, I've attached this project for you to this lecture. So simply download it and then do npm install and then ng serve. Now, if you head over to localhost port 4200, you get our familiar Angular 2 app. So now let's start implementing Redux in this application. First, I'm going to go in the source folder, under app, add a new file, store.ts. Here I'm going to export an interface called iapp_state. So this interface determines the shape of our store. For now, we're going to leave it empty, but as we go through this section, we're going to add some properties to this interface. So this interface will determine what properties we're going to have in our store. Now, I'm also going to export a function, which I call root reducer. So we start with one reducer function here, and as our application grows, we can break down this function into smaller, more maintainable functions, each focusing on one domain in the application. Now, as you saw in the last lecture, each reducer takes two parameters, the current state and an action. And it returns a new state. So for now, I'm just going to return the state that we get here. We are not going to implement a switch case here yet. That's going to come in the next lecture. So this is a very basic reducer. It doesn't do anything. All right, save. Now let's go to app.module. On the top, we need to import a couple of types from ng2-redux. So import from ng2-redux. First one is ng-redux, and the second is ng-redux module. Now we need to import this module into our main module, and that's used for dependency injection. So ng-redux module. Now we're going to create a constructor for app module. This constructor should get an object called ng-redux, which is of type ng-redux that we imported on the top. Now this type is generic, so we need to specify a generic parameter here in angle brackets. And what we pass here is the interface that we declared earlier. So this interface determines the shape of our store. So I'm going to go on the top, import iapp_state and root reducer from current folder/store. Now, back in the constructor, I'm going to use iapp_state as the generic argument for ng-redux. And the final step, we use this ng-redux object here and call configure store. This is to initialize our store. Now, the first argument to this method should be our root reducer. So root reducer. And the second argument is our initial store. So I'm going to pass an empty JavaScript object. This is our store object that will eventually get updated as we go through this section. With this, if we save the changes and get back to the browser, the application should still work and we shouldn't have any errors in the console. So let's double check that. Okay, here's the console. There's absolutely no errors. Perfect. So we have successfully installed Redux in this project. Next, we're going to work with actions. All right, now let's see how we can use actions. So here in App Components template, I'm going to add a button, call it increment, handle the click event, and bind this to the increment method of our component. I'm also going to add a counter here. So when we click this button, this counter is going to be incremented. Now let's go to App Component, declare counter here and initialize it to 0. And then add the increment method. So in a typical Angular app, this is how we implement this method. We modify the state directly here. However, when using the Redux architecture, we don't modify the state here. Instead, we dispatch an action. This action goes in the store. The store knows our root reducer, so it passes the action to the root reducer. And then the reducer looks at the action, and based on the type of the action, it will return a new state. And then the store will update its state internally. So let's see how we can implement this. First, I'm going to go on top of this file and import ng-redux from ng2-redux. So this is the primary type that we work with in Redux applications. Now I'm going to create a constructor and inject ng-redux here, ng-redux. Now you remember that this is a generic type. So here we need to specify a generic argument, which is iapp_state. That's the interface that determines the shape of our store. So I'm going to import iapp_state on the top. Like this. Now back in the constructor, I'm going to apply the private modifier here so we can access this in the increment method. Now instead of modifying the state directly, we're going to call this .ngredux.dispatch. Here we need to pass an action object. And as you learned earlier, an action is a simple object that has a type property. So this is how we dispatch an action. Now some actions may carry extra data about the event that just happened. For example, if the user posted a message, here you can have properties like body, subject, and so on. But in this example, we don't have to worry about that. So delete. Now every time we define a new action, we need to go to our reducer and determine how the state will change in response to that action. So let's go to store. Here I'm going to add a switch statement on action.type. And if it's increment, I'm going to return a new state with updated counter. So currently it's not clear what is the type of this state object. So I'm going to apply a type here. This should be of type iapp_state. So we get the current state of the store and then we'll return a new state. So again, I'm going to add a type here. This function will return iapp_state. And now because we need to work with a counter, we need to store its current value in the store. So in iapp_state interface, I'm going to declare a property counter of type number. Okay. And now in response to the increment action, I'm going to return a new object with counter set to state.counter, which is the current value of the counter plus 1. So note that I'm not modifying the original state here. I'm returning a new state. And the final step. Earlier in app module, here we passed the initial state of our store. Now we have a red underline here because our store now has a counter property that we have not initialized. So back in app module, I'm going to set counter to 0. So let's quickly review the steps, and then I will show you how to improve this code. In the app component, we injected ng-redux in the constructor, and in the increment method, instead of modifying the state directly, we dispatched an action. Then we went to our store, we modified the root reducer, and added support for the increment action. Now, as part of this, we also had to modify iAppState, so now we have this counter property. And finally, in the app module, we modified this line here to set the initial state of our store. Now, there are a couple of things we can improve in this code. The first issue I see here is the use of this magic string in two different places. We have used this in the app component and also in the store. Now, the problem with this is that we have duplicated this in two different places, and if we have a typo in the code, our code is not going to work. So it's better to extract this into one place, define it as a constant. So this way we won't have a typo problem, and if we want to change this to something else in the future, there is only one place we need to change. So in the app folder, I'm going to add a new file called actions. And here I'm going to export a constant called increment and set it to increment. Now we can replace those two magic strings with this constant. So first in the store on the top, I'm going to import increment from actions. And then I'm going to replace this magic string here, increment. Now to save time, I'm going to copy this line and go to app component, on the top, paste it, and once again, replace this magic string with a constant. That's the first improvement. Now the second improvement. You notice that when we changed iAppState here, we had to go to the app module and modify this initial state object here. So we are going back and forth between different files, and this is really not good practice. So let's go back to the store. Here I'm going to export a constant and call it initial state. This is of type iAppState, and I'm going to set this to this object with counter set to 0. Now next time we're going to modify the iAppState interface, we can immediately modify this initial state if necessary. We don't have to jump back and forth between the store and the app module. So now let's go to the app module and import initial state from the store, and then replace this object here with initial state. Now, if you run the application at this point and click this button, the counter is not incremented, because we have only implemented the part for updating the state. Reading the state from the store is something else, and that's what we're going to look at in the next lecture. Hey, thank you for watching my YouTube video. My name is Mosh Hamedani, and I'm a full stack developer, a Pluralsight author, and a Udemy instructor with about 14 courses at the time of recording this video. So I've got lots of courses on both front-end and back-end development, including C#, Entity Framework, ASP.NET MVC, Angular, architecture, unit testing, and so on. This video you watched is actually part of my Angular course on Udemy that you can get with a discount using the link in the video description. And if you want to see my other courses, simply head over to programmingwithmosh.com/courses. You can also subscribe to my YouTube channel to get free videos every week. Have a great day, and I'll be back soon.